In this section of the PPST, we will look at ordering integers, fractions, and decimals. Before we look at that, let's look at some definitions of our real number system. Our real number system includes both rational and irrational numbers. Our irrational numbers are like the number pi, in which the decimal never repeats nor terminates, although we usually round pi to 3.14. Rational numbers include our set of integers, whole numbers, and natural numbers. Rational numbers are fractions such as 2/3. We can also represent it as integers like -7, or as decimals that repeat such as 8.3636 repeating. Let's look at some of those definitions. Rational numbers are classified into different subsets. Again, we can look at our set of natural numbers, which are really just our counting numbers like 1, 2, 3, 4, and 5. Our whole numbers are made up the infinite set of those natural numbers plus the number 0. Therefore, all natural numbers are whole numbers. But there is one whole number, namely 0, that's not a natural number. The integers are our positive and negative whole numbers, including 0. Therefore, -1 is an integer, but it is not a whole number. As for our rational numbers, we can either express them in fraction or decimal form. By definition, a rational number is defined as a ratio of two integers, a over b, where a and b are integers, but b is not 0 because we don't want to divide by 0. Examples of our rational numbers are like 3/4, -7/5, -2, because we can express it as -2 over 1, 0, and 4. Therefore, all natural numbers, whole numbers, and integers are also rational numbers. Decimals are another way that we can represent rational numbers, and all decimals for rational numbers either terminate or repeat. For example, the decimal, what we normally call 0.23, is really the rational number 23 divided by 100, or read as 23 hundredths. We can order rational numbers on the number line. For example, we say -4 is less than -1 because we can add a +3 or move 3 places to the right to get to -1. Therefore, we could also say that -4 is less than -1 because it falls to the left of -1, much like 1 is less than 4. In order to order rational numbers, we can use benchmark fractions, such as 1/2. We can find common denominators in order to compare the numerators, or we can put it in decimal form and compare along place value. Let's look at the first and second method. We want to order the fractions 2/12, 5/8, and 2/5. The first thing that we can recognize is that we know that 2/5 is less than 1/2. We can see that on our number line. But we also know that 2/5 is equivalent to 4/10, multiplying both numerator and denominator by 2, and 1/2 is equivalent to 5/10. We know that if we had 10 equal-sized pieces and we want to select 5 of them, we would have more if we selected 4 of them. Likewise, we know that 7/12 is greater than 1/2 because 7/12 is equal to, well, call it 7/12, and 1/2 is equivalent to 6/12. Therefore, 7 parts out of 12 are more than 6 parts out of 12. Finally, if we want to compare 5/8 and 7/12, we will see that the common denominator is 24. Therefore, 5/8 is equivalent to 15 parts out of 24 equal-sized pieces, and 17/12 is equal to 14 24ths, which makes 7/12 smaller or less than 5/8. Therefore, we can order the fractions accordingly on the number line.